Before checking your table for squareness to the spindle, it's a good idea to make sure that your table is cleaned up and put a little oil on there. Stone it down. If there's any scratches or chips in it, you'll minimize those. So I've already pretty well done this, and we're just finishing up here now. Now all we've got here is a 5/8 bar, 5/8 by 5/8, and it's 7 inches long. I've drilled some holes in it here, and where this indicator is, and that indicator is, and also another one here. The distance between those holes, in this case from here to here, is 4 inches, and from this hole to that hole is 6 inches. Now the holes will be the right size to accommodate the stems on your indicators. Now what we're going to do is check for squareness in this direction. So I mounted these in here. We'll bring them down. Make sure they're both resting on a surface, and preferably somewhere where there's no dings in the surface, and drop it down about 20 thousandths and lock your depth in. So make sure that both of these are on 0. Now I've left the pulley open up here, and I'll be able to turn my spindle from the pulley up top, and we'll rotate it 180 degrees. Now we were 0, 0 on the other side, and we'll take a look and see what we've got after rotation. Okay, after the rotation, here's what we have. On the right-hand indicator, we look to be pretty well right on 0. And on the left indicator, well, maybe half a line out. So each line is 0.02 millimeters. So we've got a 0.01 millimeter difference. That's pretty darn good. Now we're going to check in the other direction. That's back and forth, left to right on the mill. By the way, that 0.01 millimeters translates to about 4/10 of a thousandth, I think, something pretty close to that, which is really good right from the factory. That's a good idea. You want to be able to read these, and after we rotate it 180 degrees, we're going to have trouble getting back in there to read them, so we can change the orientation of these so they face out like so. And we'll do that over here as well. And again, we'll bring that down. Bring it down, move it in about, I don't know, 20, 30 thou, something like that. You don't want to go too deep. Make sure they're both touching. This one here looks like it needs to come down just a teeny bit more because we've loosened it and moved it around. And we'll have to come down on this a little bit more. There we go. We'll 0 those. And we'll 0 this one. So we're on 0. And again, we'll use the pulley to turn this around and see what we've got after rotating 180 degrees. So on this one, we have moved 2 lines plus. And on this one, we've moved 2 lines negative. So at 0.02 per line, that would be 0.08, which is not wonderful, but for a cheap machine like this, it's not so bad. I think that boils down to about, I've calculated this before, about 1.3 thousandths per inch out. There's nothing I can do about this. As far as I know, there's no adjustment for that. But it's good to know how far you're out. If you're doing something that's long and you don't want to see that error, at least you could do a little bit of shimming, perhaps under your vise or whatever else you're working on, and correct the situation. Just to give you a better look at this, We've got, this looks like I put a 3/8 thread in here. And when you put that in, you need to make sure that it is quite vertical to the red bar. And there you have it. That's easy to make, and it's always good to know if you're having an error where it came from. If you'd like to be notified of other new modifications, please click on the subscribe button. Thanks for watching.